Today we're looking at the CLI package. As the name implies, it is a beautiful package to create beautiful command line interfaces. As I execute my script, you can see that information is flowing to my console in a beautiful and structured way. There's a lot of stuff going on, and we'll learn how the CLI package makes this kind of thing possible, and this will help you to make your one-off scripts more informative. And if you are running live automations in production, then you'll definitely have a use for this type of messaging. So with that said, let's dive in. Okay, so I know there was a lot going on in that console, so let's review it step by step. What we can see in our console here is that we have these headlines, we have a couple of steps like load data, validate data, exploratory summary, outlier detection, just mocking some typical data analysis steps. Here we fit a linear model and then we report stuff and then our analysis is complete. Hooray! In between those steps we have these blocks. They are all indented. They come with these kind of nice, beautiful icons, and also there's a lot of color in there. And as I was executing this, let me actually close this again, or like get rid of the whole log. Let me re-execute my script that you currently don't see, but you see in the output that there is a progress bar right at the bottom here showing me the progress as things are flowing to my console. So that's pretty neat, and all of this is funneled through the CLI package, and we're going to build out the components here. So as I scroll up here, we see that, okay, we start with these type of headlines. And for that, the CLI package has a set of H functions, H as in headline, and as you may know from HTML or other kind of markup languages, you often have headline level 1, headline level 2, and so on. The CLI package has a function CLI H1, H2 and H3 for headlines of level 1, 2 and 3. I think the naming is pretty clear, and you can see that these type of different levels create different type of headlines. So in this script here, I'm collecting all the different types of functionalities, and in this other script I have here, I want to assemble my real pipeline that we have seen in the beginning of the script. So let's throw in the pieces that we have seen in our final recording. So we have first the headline card performance analysis, and then we have our different steps like step 1, 2, 3, 4, 5, 6, and finally another H1 headline to say our analysis is complete. So as I clear my console and then re-execute this, you see that there is our basic structure for our CLI. Next, we have seen that our output was able to create these type of messages with different icons in them. In the language of the CLI package, these are alerts, and you have different kind of alerts for different kind of symbols. So you could do CLI alert success, a danger, warning, info, or just a plain CLI alert. Let me actually make some room here. And then if we execute all of this, you see that, okay, nice. We have these different kind of icons in here, and we also have some colored styling inside of our messages. And the reason why this happen is because everything that we throw into curly brackets can use some inline style classes. For example, we could throw in the dot file in here to say that this thing, this data CSV, should look like a file normally looks inside of a CLI message, or a URL should get these brackets around them. Or there's also stuff like package or value. For example, value will wrap numbers or whatever you put in there into quotation marks. So equipped with these messages, we can now add them to our script. So making some room here. Now for each step, we can throw in the corresponding CLI messages. The first one is pretty easy. We just throw in CLI alert reading a specific file and it will give us that. Here we're faking this, so let's just not read a CSV file, but instead let's just use one of the built-in data sets. We're not really doing any data analysis here, but I do want to show you one thing. Namely, you can run calculations on any variable like the data set that we have here and use that as part of your messages. For example, you could use CLI alert success and say that you've loaded so and so many rows. This n row cars will evaluate to a specific number, and you have loaded these amount of columns here. So in total, you'll get this type of message. But you might now wonder, hey, why is this evaluating as code? And in here, this thing is not evaluating as code. The reason why is because we have combined this with an inline class. If we were to not do that, then we'd see that, okay, this gives us an error message. So because we have added this class, this thing here was evaluated as a text. And if we wanted to combine a class for specific styling with an evaluated value, then we do have to use another set of brackets. And in this case, it would of course cause an error here. So let's get rid of that. So with that, we can throw in all the other alerts, something like using a specific function notation. And then we fill in all the other sections. We can even use some code logic to throw different types of messages. We can even use pluralization inside of our messages. So this will become values or value depending on NA. Here in our example, we don't see that because this thing is just 0. And then we can throw in more code for more sections. And I really shouldn't have let AI make up so many things, because now you have to watch me insert those. So there you go, this is our full thing. And now this is starting to take shape. You can see that, okay, this went through pretty quickly, but we do have all of our messages here. And the one thing we haven't seen yet here is that maybe we don't know how this computing average with MPG got green. So let's look at our code. And there we see that the inline class for that was a field. Here in our outlier detection, we can see that this is called one outlier, but we see that we have this pluralization as here, which wasn't triggered because this number evaluates to 1. So with that, we have unlocked yet another technique for the CLI package, but notice how all of these steps here are not really indented. If I re-execute my prepared script that you still don't see, I'm always teasing you with the thing we're still going to build, so you have to watch all the way to the end. But in any case, in the console, you see here that these steps, these messages are indented. And in our current output, they come all at once. That's because in my prepared script, I have some wait time included. We'll also add those, but we'll also see that, okay, these things here are not really indented. So let's change that. And the way to do that is to create a new section. And as you might know from HTML, these types of things are often called divs. So that is why the CLI package also calls these divs. And if you start a div, a section, then you also have to end it. And in between, you can throw in anything you want. For example, we could use the CLI text function with the emphasis class to emphasize custom inline style defined in this div. So far, the div doesn't do anything spectacular, but we can make this more interesting the moment we apply a theme to the div. The way to do that is to set the theme argument to a list of classes that you want to target. For example, in inline text, these are called spans. You can target the emphasis class and then specify things like the color. So if you are to execute this now, you see that, hooray, this thing here now got orange. You don't see it as I have highlighted it, but here you do. So that's pretty much how these divs work. And now all we have to do is to create a div that uses a theme that indents everything. And then we have to apply it a couple of times. And in order not to repeat ourselves, let's actually wrap this into a function. So we're going to create a function called stepDiv. And inside of this function, we'll of course use CLI div that we've just learned about. And then we're going to assign a specific class to this container so that we can style this container via theme, where we say that let's target .stepBody, so this class that we have just defined. And in there we can say the margin left is supposed to be 4 indentations. So now we can use this function for our different parts. So for example, in step 1, we could call this function, and then at the end of the step, so all of this here is step 1, we could do CLI end. And now as I execute this, you see that this part still looks the same. So let's try to copy this over here, and then let's retry to execute this. And now you see that this stuff was indented. So our code was correct, but due to the fact that we have used this div inside of a function, it is automatically closed when this function terminates. And this happens basically right after creation. So we can say that we use .autoclose and set it to false. And now we don't need this stuff here anymore. And as we execute this stuff, we see now, cool, this indents my code now, or rather it indents my output. So now we can apply stepDiv after each step H2 and before the subsequent headline. So due to the power of video editing, you don't see that I have done this, but when I get rid of my console content and re-execute this, you see that, hooray, everything is kind of indented just the way I wanted to. But we are not done yet. The CLI package has a couple of more styling tricks up its sleeves. If I re-execute my prepared script, you'll see that, okay, there is still this progress bar we haven't covered. You see that there are these list things that we also haven't covered yet. And I think other than that, we have basically covered everything. We've also seen how to make this text orange, but I don't think that we have added it yet. So we will have to do this now. And also here we have a numbered list. So all in all, we're pretty close to the finish line. We just have to add these lists and also the progress bar. For the list, it's actually pretty easy. There's another set of CLI functions available to you. For unordered list, you use the UL function, just like the HTML way to do it. This will give you a list like this with these bullets. Then you have an ordered list, which is a sequential list, so that's why this is called OL as an ordered list. And finally, you have a definition list, a DL, which can use these sorts of things you want to use as part of your listing thing. I don't know what is the term, as part of your bullet, but it's not really a bullet, it's a text. That's the thing you use here. In any case, that's a definition list, as it's called here. And that's what you can do with the CLI DL function. And you can construct a nested list by using the UL, for example, for unordered list without anything, and then closing it with CLI end. And then you can throw in a list item, and this would give you something that looks like this. And if you want to go another layer of nesting deeper, you can throw in, or you can basically repeat this step and throw in more list items like so. And then you have a nested list. So for our analysis script here, this means that we can throw in a couple of things in step 1. For example, after this inspecting column types, we can throw in this message here. Notice that this also gives us the green coloring from the field class. So you can also use this type of stuff here. For the computing average section by cylinder, you could run some calculations and then display those. And in the linear model section, you can throw in the text we have forgotten earlier with the custom theming for R squared. So this will give us this part here. And then we have this definition list here, which would give us this sort of thing. So that way we could easily show the coefficients of a linear model. And now as I execute this, we see that this is our script so far. This doesn't look too nice because my spacing here is off. And you can see here that I still have these indentations. And after calling CLI end a couple of times, this is back to normal again. And the reason why this happened is because earlier when I demonstrated our step div, we didn't close it before. And so this thing never got closed. So that's why we had these indentations so far. All right, cool. We're almost at the end. Now what's left is the progress bar. And this also gives us a chance to throw in a bit of sleep time for our R session so that this looks more natural, just for the sake of demonstrating how cool this looks. If everything just is thrown immediately into the console as it is right now, it doesn't look too convincing. So let's try to make this nice in combination with the progress bar. So what we can do at the beginning of our script, I'm not showing you it in the separate script because it really makes only sense to incorporate this here. We can throw in a progress bar or variable that is filled via the progress bar function. It will have a name. We tell it that it's supposed to clear to disappear once it is finished, and it will have a total of 11 plus 20 steps. And just so that you can see it in action, we can create this thing, and then we can simply CLI progress update this thing via its ID. So we see that as I call this, it will actually update. And if I call this a bunch of times from the same call, basically, you see that here only at the end. And if I were to throw in sys.sleep in between, like 1 second, so like this, and then execute this, you see that this is slowly progressing. So if I were to once again re-execute this, so once again, this is progressing. So to finish off our script here, we can create a function. Let's call it pace. And in there, we're just going to wait a couple of seconds, and then we're going to call this progress. And so all that is left to do now is to simply throw in this paste call a couple of times interspersed in my script. And because I don't want to do this manually and we're already at the end of this video, I will just copy in this thing here from my prepared script. It's basically the same thing. And now as I call this, we see that our progress bar is updating and we have all of these paste calls in between here just for a bit of waiting time. And in case you're wondering, why did we set up our progress bar with 11 plus 20 steps? Well, if we look for pace, we see that, okay, we have it called 11 times. So the first 3 times here are just notation that we have in here where we see this word. Actually, we can look for paste and then start. We see that it's called 13 times and we see that 20 of those are inside of a for loop, namely in this one here. So all in all, this will complete all the steps. And as we execute this, we see that our progress bar makes progress, but at some point inside of the loop, it will make a lot of progress. So there is the looping, it's becoming faster, and then we're done. And we are not just done yet, because I actually remembered I forgot one silly little thing that is really cool about the CLI package. Namely, you can collapse things really easily. Let me just show you with some fictitious examples. If I execute this code here, you see that by default everything is collapsed even if I stick vectors into my CLI functions. That's pretty neat, and via the or and class you can specify whether they are collapsed with an and at the end or an or, and you also have a way to pluralize with is and are, once again using the same question mark notation here. So these are again a couple of nice little tricks that the CLI package can do for you. And it also helps you for really cool error handling, which I don't want to cover here because this video is already getting way too long. But if you want to get really advanced at error handling using tools from the CLI package, I encourage you to check out this video here next. So I hope that you enjoyed this video, and now with all of that said, I say thank you for watching and I'll see you next time.